Well, hi, good morning. Thanks for joining me in my shop here. August 28th it is. And is today going to be the day that I finally get this guy working again? Well, I think there's a good chance of that. or I wouldn't be in here. So, this is definitely among the oddest things I've come across. But I have to tell you, I've had many experiences, and if you do this kind of work, you probably do, where you stare at your project telling yourself, it cannot be, it cannot be, it cannot be, but there it is. So, I have a situation here where if I plug a tube into that socket, a short occurs. Or at least it appears to be a short. Now, there's some tight parts in here, so we're going to take a close look to start off with. The tube's in the socket right now. My imagination says when you push the tube in, one of the pins is reaching up through the bottom, going down, reaching up through the bottom of the socket and touching something. And I aim to see it. That's what I'm going to try to do. Well, let's take a look here. Now, this isn't the best camera for doing close-up work, but my usual close-up one is... the automatic focus is on. I just hang on a sec. I'm going to shut off the automatic focus here, or we're going to be going crazy. Okay, let's try this. It's on fixed focus, so bring down our light here. Now, I don't know which pin it is. Let's just look at this thing. Maybe we'll start with pin number 1. We'll just look at it. Pin number 1's got those 2 resistors on it. That's pin number 1. Certainly looks like nothing could happen there. See how the pin comes up quite a distance. You know what? This is what we're gonna find. When I get around far enough, we're gonna find a pin that's contacting something under that resistor. What's under that resistor? What's under there? Nothing. Nothing is under there. Oh! What's going on back there? And I got a pin thrust into the middle of a resistor. Let me look this way. Wow. Okay, so there's a pin. It's coming up towards the body of a resistor, but it's not touching it. So what happens? You shove a pin into one of these things. Those little clamps open up a little bit, and the pin comes through, and the tab here that things are soldered to will move a little wee bit. A little wee bit. But you just wouldn't imagine it to keep coming back to exactly, well, not exactly, almost exactly the same resistance every time. Oh, what's that going on down there? Hold on. Is that, no, that braid looks like it's soldered there. So right, it's hard for me to describe what I'm seeing. I looked away momentarily. Well, the braid is soldered to those 2 pins using the poor man's stereo view. Well, it certainly looks like there's a lot of stuff jammed under there. So the braid appears to connect to these 2 terminals and then slide underneath that resistor and get soldered down there to a little out of focus. But right on the left corner of the lower resistor, no, I don't, I was going to say it looks like the braid might get in there. Well, we'll poke it. We'll poke this. I'm not seeing anything here that is coming out at me and going, hey, look at that. there it is. Very odd. Okay, I'm going to get the meter set up so we can read that resistance, and we'll start poking around in there and see if we can make the resistance come and go. Okay, here we go. This stick has saved me many other radios. Maybe it's going to save me on this one. So we'll start with pin number 1. Guess what? I've done this already, but we're going to do it again. Did this a couple days ago. I couldn't have done this a couple days ago. Okay, this one is very likely a problem right here. Nope. This one could be the problem. Nope. Okay, there's a piece of braid down there I can push on. Solid as can be. $74 now. What I'm doing is a stupid thing. I'm using my thumb to heat this capacitor up a little bit, but I don't think it's enough to do anything. Holy smoly, that didn't do anything. What if I pull the tube out again? Darn difficult tube to get at. Okay, well, let's wiggle again. Starting with 1, pin 1, 2, 3, 4. Of course, these move a lot more now. 6, 7, 8. This is just, you know, it's starting. Yeah, I'm starting to think it's something actually internal, right inside the socket. That's crazy. That you wouldn't expect a stable short. You expect varying resistances. Now this has varied a bit, 164 to 172. And you would think if that's a problem, flexing these terminals at some point, you would see something happen. For sure. At least I would think so. What if we try shorting 2 terminals at a time? We assume that what's going on is the tube, by putting it in, is somehow joining 2 terminals that don't normally join. How that would happen, I don't know. I have a clip lead here. Let me just check and make sure it's working. It's not working. What happened? Oh, look what I did. What I want to do is this, and I want to test over here. Hey. What gives? How come I don't get a 0 on here? So my voltmeter acts up all the time. Voltmeter and that. That's good. Have I got an open clip lead here? Must be the one I was using. Okay. Now what I'm going to try here, as soon as I test this clip lead, I think what I would want to try can't finish the sentence. Nothing wrong with cold bleed. Who knows what happened there? Ground. I'm going to try just putting a ground on each one of these terminals and watching what happens. Tube is out right now. Haha. So that's something. Oh my gosh. So I just put that right on the stator. Get a 0. Does that make sense? 0 on the stators. So the stator on the capacitor, well, it's one side or the other here. One side or the other. Stators are on the outside. Of course, you can't separate the rotors. They're all grounded together here. They're grounded, so it must be coming to the stators. So I apply, and then I'm on pin 6 here. I've clipped on at this point, and I get a 0. If I clip onto the ground, what? Well, that's because I'm reading back here. Right. So what have I done? I've done nothing. Yes, I've done. Yes, what have I? I must remember, I've disconnected a grounding wire from underneath. So is it a chance that ground is missing while I'm doing all this? And that's bulkifying everything. I don't know, let's keep going. I'm just picking up information here. So this one gives me the number. This one gives me a 0. What's the next one do? Open. Well, that one gives me the number too. Well, this is pretty interesting. And what about this one? This one must give me the number. Give me the number. They have 3 terminals. Okay, so 2 of these terminals are soldered together by the braid. 2 of them are soldered together by the braid. So that makes 3 terminals in here that you can clip this on and get, because all 3 of them are connected together. 3 terminals tied together, you get that. No tube in. Okay, well that's certainly something to look at. Let us look at it. So, pins that are tied directly together. Externally it'd be pin number 1, 2, 3, 4, 5, and pin number 9. Pin number. So what they may be doing here is grounding out unused terminals, or 5 is one of the heaters, isn't it? 4 and 5 are the heaters. One of the pins involved here is pin number 5. Pin number 5 is brought to a terminal that is grounded. Pin number 5 is grounded. Pin number 5 is grounded, 9 is grounded, and 8 is grounded. None of those appear here. 8. 8 appears here. 8 is grounded. 8 is grounded, and along with it they put grounds on one of the heaters. So we look at the heater string, 6PQ7, pin 5 is on the ground. Pin 5 is on the ground. Pin 5 is what we're on right now. But they're on the ground You know, this really isn't a problem of a ground. This is a problem of a lack of ground. No, am I making any sense? I don't think so. Let's try it again. Pin 5 here, 6BQ7, pin 5 is grounded. Pin 5 should have a solid ground on it. So now we look at pin 5, count them, 1, 2, 3, 4. Pin 5, it's not solidly grounded. It's actually the opposite problem. The ground is missing underneath. I got to put that ground back on. If this whole thing corrects itself, then I'm going to fill my pants. If that, because that can't possibly correct it. Just take everything off here. Just make sure we're wired up properly here. Okay, and the screw, I fortuitously saw it here this morning. I picked it up, and I less than fortuitously put it back down. There it is, right there. You got a tool with something like this. Out of focus, unfortunately. That didn't really show much, did it? The reason I'm not too worried about that connection is because I think there are others, but yeah, I should be finding a ground, and I'm finding now that doesn't make 100% sense either. So nothing's making sense. It's another day in my shop. Everything else okay under here while we're looking? Yes. I didn't undo anything else. Yes, I did. I undid this capacitor. I better put it back. Okay, I'm going to solder that back. Let me just show you something I found in the manual here, hidden away in an unexpected place. So underneath the chart in this instructions here is this statement. Bias voltage across the inductor primary terminals. 6 volts on bands A, B, and C, 15 on band D. Oh, I wish I had seen this or picked up on it, because I could have just done this test early on and discovered that everything was fine with the bias stuff instead of the dumb things I did. I did this test now. There is roughly 6 volts on bands A, B, and C. It's always the same, and roughly 15 on band D. It's like 15.8 or something like that. So that appears to be okay, even though I brutalized that circuit earlier on. Now we've got everything back in place here, except the tube is not in. And I've forgotten what my big plan was here. Oh yeah, we had just discovered that three of those pins are connected. Now let's see if we can find a diagram showing that. So we're looking for all the stuff around here. Not on this diagram. Oh. No. How's that even go? Not this one. Let's try another one. How about we try, I can't find them. We'll use the ones that are in the book here. They're not in the book. They didn't put them in the book. Here they are. That's underneath. This is getting close here. Showing a little bit of it here. They don't show a finished version of it except in those other diagrams. Oh well. Okay. What's happened to those other diagrams? Okay, so I reconnected that ground lead and repeated some of the measurements here just before I flipped the camera on. Can you hear a tone in my voice? So this is the point which turned out to be grounded, which kind of shocked me because it's the stators. No tube in. All I did was connect the ground. I'd repeat the test. Now the 170 is there. And the parts that were showing the 170, the 3 terminals tied together, grounded. From connecting that ground lead, turn these around. Huh? Huh? I must be seeing things here. I have to be seeing things. Okay, we're going to take it off again. Remove this ground. The path to ground is where'd that fancy tool go? The path to ground is through the, I don't know. Ground is off. Screw is here. Now, same test. First, the stator. It's just gone totally open. And this other thing, it's gone open too. Come on. Well, that makes more sense to me than maybe I just got it turned around in my head. I don't think so. I was getting one when I was doing this before. I was getting 164 there. Well. My guess is there's other ground connections coming out of here anyway. Shields and stuff that I never separated. So putting on and off that ground thing shouldn't really make any difference. Oh my god, this is just getting into, it's turning into another schmozzle. A schmozzle. Okay, if it's a schmozzle. Wow. How can, there just isn't that much left here to puzzle over. Yet it's still a puzzle. So this test moments ago was showing 164. The ground is out. And then if we go on the stator, it's also showing nothing. Why? What's going on here? Oh. Checking my meter and clip leads. Well, I. It seems to be different. I don't know. Am I losing my mind? Yes, I am losing my mind. There's no question about that. How come it changed? What did I do that changed it? Put the ground on and off. Well, I think I can reach up in there and just do it by hand. On. Off. On. Off. Well, as far as this terminal is concerned, I better put that back on because wait a minute now. It's affording an opportunity with it off. So if we go back to the original test, which is here, we have nothing. And if I push the ground on, there it is. Boy. So if it were an easy thing to isolate away the ink reductor, I would, but it's not the easiest thing. It's got these, let's think about this for a minute. It's got these bands, but they actually are just passing by the ink reductor. The primary terminals down below seem to have the right stuff on them. All we're left with is the 4, or however many it is, wires coming from the resonating coils. I gotta stop. Drink some coffee and relax here. There's too much bumping around in my head for me to sort it out. Okay, so I've just been fiddling around here and trying to get a grip. And my grip is even looser now. I pulled the tube out, expecting the 172 to disappear, and it's still there. What's happening here? So that reading is from this point, that's right here, around to ground. Ground being found, oh, I'm finding the ground up here, because I have the wire detached underneath. Could that somehow be different? Actually, this is the meter ground. The actual attaching of the ground is the white clip. You can see the bottom of it over here. Let's just remove it and see what happens. Then nothing happens. So I get the tube out, round off, but still getting it. What is happening here? So I'm reading to here, to the frame. Let me read to this chassis, and we'll probably see it disappears. Yeah, it's not there now. Okay, so I put the tube in. No. I attached the ground properly over here. I'll just do it with my finger here, and we'll see the one. There it is. So I remove the ground, but if I attach a temporary ground to various things up here, there it is back. Of course, that's the wrong thing I'm doing there. That's all this. Yeah. With the tube out. With the tube out. I thought you put the tube in to get that reading. Okay, let me put the ground on this way. Get the reading. Tube is out. We'll stick the tube in. It's an intermittent type of problem. You know, you gotta anticipate it being inconsistent as you go, but that doesn't help any. Okay, tube is started, and the tube is in. Didn't do anything. Didn't do anything. So if there's a mechanical thing going on, maybe I've created a situation now where it's kind of permanent. Whatever it is. Holy smokes. Let me put the ground on down below. Just maybe there's some kind of difference. I can't imagine. The ground screw is coming right into the frame of this capacitor from underneath. Can't imagine that would be any different. Acts of desperation in troubleshooting. When I encounter these kinds of things, and it happens with some regularity, I just don't seem to make sense. It often comes down to a ground that's not in place, that's supposed to be there. Or the opposite, of course, there's a ground somewhere. Or the worst one of all for me is I've proven something to be a certain way and I made a mistake. It's not that way, but I got that in my head. Carry on for ages. Not going back to the area where the problem really is. Maybe we should operate this thing at this point just to see what the heck is left of it. Because I don't know what else to do here, unfortunately. Yeah, let's operate it again, just to see. One of the things we can do when we operate it, we can test the test for the B+ voltage, reaching the plate of the tube here. Plate of that tube is on pin 6. Voltage is controlled by this tube. So if this tube is going wild, the current drop through here will result in a low or no B+ up here. This tube was going wild because I got a minus 28 volts here when I measured it quite some time ago. That's another thing that's just burning me up. They must be related. All this stuff's got to be related. It's all hooked together with wires. Of course it's related. Okay, so we're going to try powering this guy up. We're going to read the B+. We're going to look and see if it's, by some chance, it has started working for reasons, who knows. Put on my FM radio over here. I just have a little transistor radio going at 100 megahertz. The output from here, oh, I took it off. Oh. I wonder if I tested the output a couple of times and didn't realize I didn't have the cable connected. Okay, putting it on the standard, the all-around RF output here. Okay. And everything's ready to go. Tubes are in. All tubes in. Let's just neaten up the situation here a little bit. Get myself into some kind of trouble here. And we want to watch the voltage appearing. You know, I'm gonna poke it with this. The voltage appearing. Okay, we're plugged in. Going through the dim bulbs to start. I think we're okay here. Still a little bit of a mess, but we're okay. Switch is on. Here we go. What was that? Wait a minute. What was that little pop? Nothing. I hadn't thrown the switch yet. Here we go. Dim bulbs say everything's okay. Look on the high side. We'll watch the high side of the this guy here. See the voltage come up. Nice view of the meter. There we are. Okay, we're watching this point. Ooh. What happened? This point. So 30 volts are available for the plate on the high side of the radio frequency coil. On the other side, there's just nothing. There's nothing left. The situation's worse than ever. What is going on? So how come so low on the high side? Because it's really pulling current through something. Yeah, let's just check, because I've been fooled before thinking things aren't working when they are. So we have a fine attenuator in the middle, so it can't be at 0. Listening. Nothing happening. Okay, I'm going to do the same thing with the marker amp. I'm going to switch it on, and we're going to steer it past 100 right here. That's me. Marker amp's putting out a nice signal. I'll turn off the marker amp. That breaks the B plus to the marker oscillator, I believe. So we're exactly where we were. Now on the plate, on pin, where's the voltage table? Because I think the situation has actually gone downhill here. Yeah, I kind of wish something would just burn out and get it over with. Okay, here's the voltage table. Pin 1, 150 volts. Pin 1. Okay, it's almost there. Oh, wait a minute. Wow, there's 150 volts right on pin 1. Thumbs up. 2, NS. 3, 1.7 volts. 3. Okay. Pin 4 is the heater. Pin 5 is 0. Pin 5. Pin 5. 0. Pin 5. Pin 5 is the grounded heater pin. Pin 4 is the supply side of it. Pin 6 is the screen. No. Pin 6 is one of the plates. There's 2 plates in here. Pin 6. 96 volts. Pin 6. 3 volts. Well, we're exactly the same place. Nothing has happened here. Pin 7, minus 9 volts. Pin 7. Pin 7, minus 9 volts. Pin 7. This guy. Minus 9 volts. He's correct. No plate voltage. No plate voltage. So what is there that could pull that down? I think I can separate this terminal here, the plate terminal, from the capacitor. I'm looking to see if there's a physical, like some debris or something in there. No. So these plates read the same though. 3 volts. We got 30. Ooh, we got 30. We got 30 reaching here, but it should be much more. 37 now. How come it's different? Let's just go back a bit further. We got 3 here, 37 there. Look at this thing. Look at this thing. 37. Okay, top of the 6 CL6. Okay, I gotta tip this up while it's operating. Bad things can happen. Nothing bad happened. Okay, and we're gonna chase that voltage. Just trace it down. The next stop is pin 6 of the 6 CL6. CL6. I said 6, didn't I? I said too many things. 6. Pin 6. Pin 6 is 9. Is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. This is pin 6. So you have only 37 volts available. This suggests to me that this tube is in conduction. Let's look at pin 2 or 9. 2 or 9 is the grid. Boy, I've been down this track so many times. 2 or 9 is the grid, and we're expecting, I can't remember what it is now, we'll look later. 2 and 9 are tied together. Wait a minute, there's nothing there. No, that's wrong. This is 2. You see minus 30, and it's supposed to be like minus 8 or something like that. Table. So our CL6 pin 2 should be minus 2.4, and it's minus 30. I mean, all that's a big problem. Why don't we just focus on that for a while? How does that get to be 30 on the grid, driving this tube into cutoff? You know, I did a whole bunch of scoping of signals through this thing, and it seemed, especially from the blinking and all that, it all seemed okay. That's kind of weird in itself. Pin 6. 7 volts instead of 96. I mean, that's got to be the hint of the day. Tracing that is what got me up to thinking, like starting at this point where I am right now, got me thinking that the increductor was shot. Tracing upwards towards it. And going the wrong way, maybe. I traced the other way too. Holy smokes. This is bound to be something dumb. So what would happen if this went open? This is probably the major current path, as opposed to this 150k resistor, which is very resistive. But I checked this, it's not open. If this were to open, that would drop the voltage and just set this whole thing off. But on the top of it, we would find all the supply P+. So at the top, we'll look at either side of this 150k resistor, just above the 10. The 2.5, 10 watt. And I don't need this thing hissing at me. Okay. Come down a bit. Warming up. So the resistor in question is down here. Okay, one side, this is the side with the, look, there's 185 volts there. That's what could get to the plate of that tube if it were allowed to. Other side, the same resistor. So this is the supply side here. Supply side over 200 volts. The other side, 185 left. And here's the... Well, that's really weird. So the resistor here says 2500, and like somebody's penciled in another 0. That can't be anything. And on the other side of that, nothing's left. There's the 37. It's all dropping on this 2500. It just shows there's a lot of current being pulled. So what could pull the current? The conducting tube, but the tube has a huge negative grid. But you know what? This tube is operated in a really weird way, and I'll take that back. I was going to say the cathode can float way high. So I'm reading ground to grid, cathode to grid. So that voltage is really there, and again, it's inexplicable voltage, and again, because other side of this resistor, other side of this capacitor, same thing. There's a big positive voltage here. How do you end up with this negative voltage over here? Where would you even get it from? I'm definitely reading it to ground. Yes, absolutely. There's no chance of that being wrong. Wow. It's really very mysterious. So, look at this more closely here. Yeah, the B plus comes from way over here through this system to control the amount of B plus being applied to the oscillator. Voltage very low here. I'm thinking it's pulled down because of some fault up here. Got caught up in this resistance thing only because it's weird. Maybe the problem's all down in here. It's just as strange. How do you get a voltage on this pin? A negative voltage on this pin. Negative relative to the cathode. So one way is you push the cathode positive. How would you do that in this tube? You'd lose this ground connection. If you lose the ground connection, everything goes crazy. Maybe that's what's happened. So we check for ground on the cathode, which is pin 1 of the 6CL6. Fat chance this has happened. Pin 1 is tied to pin 7. Why would they do that? Pin 1. Oh yeah, pin 1 is tied to pin 7. 7 is the suppressor. Pin 1. Okay, we should get 0 volts on pin 1. Pin 1. Well, how do you like that? How about this one? Just get the meter to do something. That was pin 9. Pin 9. 9 and 2 are the same thing. So pin 9 is connected to this capacitor. This capacitor could be leaking because the other side of this capacitor has that on it. 37 positive. Around here. 31 negative. That was leaky. It pushed this pin positive, which is usually the problem. Oh my gosh, how do you get such a negative voltage there? I'm going to pull the tube out and measure it. Pulling the tube out, interestingly enough, will cut any current off in here, end the voltage drop that might be here, and raise the plate voltage quite a bit if I pull that tube out. So we can check for this. I'm going to pull the tube out, and then we're going to measure the plate voltage on pin number 6 up above. As soon as you squeeze on it, the heat conducts quickly. Come on out of there. Okay, now we check the voltage here. We can actually check it here. Oh, it's gone even lower. 48 coming in. 4 left after this. She's a hot one. Okay, but what we really wanted to try when I pulled it out was to find out what happens on the grid pin number 2. I have 90 volts positive on the grid. Am I doing this right? 2 and 9 are the grids. 2 and 9. So this one should have the same thing on it. 2 and 9. This one should have the same thing. So we have, what do we got there? Oh, that's strange. Look at that. So that's the positive charge on the leaky capacitor here. And I'm drawing it off with my meter, which means I'm drawing microamps off the far side of this capacitor, and that's enough to drain it out. So it's an indication the capacitor's probably okay. Depends upon the impedance of this grid circuit. The impedance of the grid circuit is like a megohm, 2 megohms. That's pretty high. I don't see how can a positive voltage cause a negative grid voltage. I mean, if this thing's leaking positivity, it's a weird way of putting it. Off and back on. Slowly charging up. So there's no negative voltage there. Some kind of hidden oscillation that's being rectified in the tube. I have a hard time believing that. I've taken my scope off camera, went through all the different places you could check for waveforms and whatnot, all through here, grid plate, all these different things, and it all seemed to be correct, or as best I could tell at that point, they all seemed to be working. But that may not be saying much. So what's this voltage become now? Let's run to pin 1, or pin 9, which is the grid, right? Screen voltage at pin 3. Somewhere in here is a problem, and it can't hide forever. Screen voltage looks like pin 6 100. Ooh, only half the screen. Well, that can be a problem in itself. What's supplying it? Nothing. Why is this point so low? So this is the screen. Got a blue wire coming from way down yonder here. Coming from here. No. No, this blue wire is coming from up above. You know where it's coming from? It's coming from right here. Going to. It's going to right there. 48 volts. 48 volts on the screen. It's supposed to have 100. Now, why wouldn't you have 100 there? All there is a screen resistor which I replaced. And I have 100 there because things aren't right on the grid and the tube is misoperating completely. Get back to this crazy grid thing. What's the grid voltage again here? Grid voltage. Plus. It's plus now. The tube is out. Put the tube in, it actually goes negative. The thing that's hooked up here wait a second here, what's going on there? it's definitely 2 and 9 are internally connected in the tube for the grid. 2 and 9. 9 has the capacitor thrown on it. When I go on the top of the capacitor, oh, the tube's missing. Tube's missing. Anyway, I get, well, you know what I get? I get a positive voltage leaking back from here. When I go on to pin 2, which has a resistor connected to it, I get a huge positive voltage. A huge positive voltage. So I'm getting a huge positive voltage because there's no current in this resistor, no drop. So I'm just reading here. And this is getting its supply through this 1 meg from down here. What's down here? Down here. We're on full power down here. It's going to go over the limit. My meter, is my meter working? 250, 240. Now I measured this over on this meter, it's 220 all the time, but it's probably more correct, 250. So we have 250 in the supply. Actually, this would be this side here. 3. This should be the side, and I think I see a blue wire. I do see a blue wire, but it's not. So how? So I'm looking for this. Well, we can find these 1 meg resistors are tucked in here. Comes to this point here. And there you are. So there we have full B plus sitting here. From this point, there's a 1 meg resistor to the terminal, and from it a 1 meg resistor up to this terminal, up here, up to the grid. We have 1 meg. Start again here. I mean, I don't think this is wired wrong. It's not what I'm suggesting at all. So this guy is connected here. Yes, they are. You can see this is actually this point and this point actually a common point. And you have the 1 meg, and this is what you get at the other end of it. So you got, so look at this. So you got 200 on one side, 100 left. So you've already dropped 100 here. You dropped 100 here. What's that supposed to be? Pin number 1 on the 12AX7. Pin number 1 on the 12AX7. Pin number 1, 70. Pin number 1, 12AX7. Pin number 1, 12AX7. Here it is. 100. And that's the drop on the first million. That's the drop on the first million. So this point is supposed to be less. Oh, right. Brings us back to this grid now. Been through this and didn't put it on video before, but we're going to go through it again. Pin 2 of the 12AX7. Okay, and its voltage is supposed to be 12AX7 pin 2 minus 8 on the 12AX7. 12AX7 is right there. Pin number 8. So we would count them carefully. 1, 2, 3, 4, 5, 6, 7, 8. 27 volts positive on pin 8. Pin 8 of the 12AX7. So that's voltage there is divided by these two resistors coming from the supply right here. Oh, what happened there? Coming from the supply here. What? What happened there? Oh, I'm on the negative. I'm pushing the. Yeah. Negative supply. Why do we get a 0 there? AC coming out of here. Maybe that's why. Because I'm actually. So the 33s are here. 33 and 33. So they're just taking the. What are they doing here? You know, there isn't a ground right on this. The ground is isolated down here. So this is the floater tube. I believe, if I got it right, basically the plate up here will adopt pretty much the voltage of the cathode. That's kind of the idea here, and something like that is going on. I'm saturated. I just reached the saturation point here again. I've gone all over the place once again. Coffee time. Boy, I tell you. I come in here thinking, man, I'm going to be like an arrow, shot from a bow. I'm going to go straight, hit the target, bullseye, done. No. Okay, so just ignoring everything for a minute. I've had this running for quite a long time now. Lots of heat has built up in this. I can still hold my hand on it, but it's getting close to the uncomfortable level. I think that's probably running hotter than it should. That would make some sense considering everything that's going on in here. But having had this on for quite a while, I now have an opportunity for a heat run test to see if there's some other part in here that's heating up. Or is this guy eating all the energy? So I'm going to use this thermal camera here. I have to do some settings on it. So I'm going to set the upper limit up to, let's say, 40. You can see what it's changing already on there. Let's go a little higher. 40. Higher yet. Okay, so now I've reduced the amount of red on the screen here. So right away, here's see how I can cover it? So that is that, and then there's two other red things. This has a very wide camera view on it, so it's kind of tricky to zoom it in on things. Something down there is 100 degrees. What's 100 degrees? What did I just see there? So the way I know the temperature with this device, there's two ways. One, it's reporting down here the hottest pixel and the coldest pixel on the screen. And then this number is showing you the temperature of right under the center plus mark. You can barely see it there. So if I find something red, if I can, so there's something right here. Okay, so that's 40 degrees, not too worried about 40. I thought I saw 100 under here. $75. If I read the highest temperature on the screen, 80, which would have to be that thing, which is this resistor here. Did I say 80? Did I just say 80? Did I say 80? I did. 80. Now that's plenty hot. It's that guy right there. 33K. It's one of the two dividers. Almost certainly it's this one. Get current pulled through it. Oh wait a minute, these are going to the, these aren't, I'm confusing them. I'm getting confused. So maybe that is okay. I mean, it's a 1 watt resistor, so it's meant to do some work. Watch it, man, this is how you get a shock for sure. I find I can feel temperature better with this part of my hand than I can with the tip of my finger. Maybe thin skin. Maybe it's the thin skin that makes the... Okay, what is the temperature of this thing? Let's take a look at it. Wait a minute. This is looking at something else. Okay, could be a tube base. So that capacitor is quite warm, but I think probably this is warm. Everything is warm. Everything. So is the capacitor at an elevated temperature. I've never found a hot capacitor, by the way. I have some problems believing it can really happen. So I think it's just picking up heat from adjacent heat. There's a little item up here that's kind of warm. What's that? Watch my fingers. Let's raise the set temperature here. 80, 90. Oh my gosh, how hot is this? $200? What's 200? That? What is 200 here? Whew. Wow, I don't want to touch something that's 200. Oh wow, okay, how did I miss these earlier? And then right beside it, 177. This is in Celsius. Well, there's no way you're going to have a 230 degree. And what exactly is it? I think it's this resistor. I got another way of doing this. Okay. Now this is just going to give a reading, and it gives you the average of what it sees. So for instance, 24 degrees C on here. This guy. Put him right up. 31 degrees. Okay, so now I'm going to try to do this resistor here, but unfortunately it's going to average everything that it sees. We'll see what we get here. 36. Okay, just squeeze it and hold it. Oh, I don't see anything making this jump. 40, 41. Where's the 200? How in heaven's name do you get 200 on this? So this is suggesting that this resistor is around, say, 50. I can touch 50. There's no heat in it at all. There's no heat in this at all. What the heck is going on? Let's go back here again. Man alive. Da. Well, has this thing lost its calibration? So this is saying, oh, you know what it's looking at? It's looking at that resistor there. That's the one with the big voltage drop. 200, 205, 200. So this guy is frying right up. He's frying right up. (200 degrees C). More than that. I get 230 on here. That sounds way too hot. So then that little resistor should be cooking up too, I would think. Can't really tell what I'm looking at here. Don't see it. So we have that guy frying. This is cold in comparison. Anything else? Anything else producing a red spot? A little bit right here. gain. You know, what am I looking at? Is it the actual ink reductor here? No, there's no heat in it. This is a little warm, but you know, this could be just heat conduction from everything else. So, you know, yeah, that's me. Wrong way. It really boils down to this one resistor is doing all the energy consumption in this unit. We come up here. Something's a little warm there. $88 and $90. Now that could be the tube socket. I don't think anything's... Ooh, 90 would hurt. Hey, that hurt. That hurt. So this resistor is a high wattage resistor. Yeah, that's for sure what I'm looking at. 100 degrees. Well, 100 degrees, eh? And then there's something really hot over here. Oh, I'm looking right into the tube there. That's what that is. So we got one. So we got this resistor hot and another resistor hot. Guess what? Those two resistors have a relationship. The really hot one is this one. 2.5, 10 watt. So they expect this to get hot. It's conducting the plate current for this tube and for the oscillator. So then the current that's being pulled through here is being pulled through the getting hotter choke. There's just too much current coming down through here. To pull the tube out, we break the current. Raise the voltage. I already did this once. How's that going to help anything? Proving this tube is conducting crazy. This really doesn't make sense. It's got a high negative voltage relative to the cathode on this tube, yet it appears to be conducting like a banshee. I've replaced the 6.8K here and with a slightly larger value. I think it was slightly larger value. Two resistors in series. Give 6.6K, slightly lower, I believe. That's hardly any difference. Well, we know this is conducting because it's getting hot, so there's no question about that. The current flow is controlled by the grid. The grid is pushed way negative. This tube should be in cutoff. There should be no current. This shows a negative voltage when read to the cathode, which is grounded. And just on the other side here is a fairly high positive voltage. Where does the negative voltage come from? It's the same quandary. I had gotten nowhere with it. Well, that's a little more information there to chew on. All that current. What about this 220? I should take a look at that. Where is the 220 now? The 220. The 220 ohm resistor. Where are you? I can't remember. 220 ohm resistor. Well, you're located off the 0.06. Off the 0.06. Up there. There's the 220. How hot is the 220? In behind here, just to the right of this capacitor, right in there. You can kind of see the silver band. Well, there's two hot things here. Wait a minute. No, that's the big 2500 resistor. Come over this way. Doesn't look hot. Okay, I got to change the setting, bring it down. And it's just to make things turn red sooner. So there it is there, 80. Well, what's the highest pixel temperature? Around 60. That's not enough to worry about. Okay, well, that's the information for today. So far, anyway. Wow. I better turn this off right now, lest I forget. This thing is still getting hotter up here. I'm sure it's getting hotter. It's really uncomfortable now. And the temperature is 56. So electrical equipment can run up to around, say, 90 degrees C. For many materials, the rate of degradation at that temperature is very low still. You go a little higher, 100, you're starting to get into a temperature that will degrade things like paper, oil, wax. Well, wax is long gone. So if you find something running at 90 degrees C, I would, in a device like this, I would say, no, that's no good, because things shouldn't be so hot that they would burn you. It's just, the tubes are an exception, of course, but nothing else should be getting so hot. Well, that's it for today. Go away and lick my wounds here.